So in the last class, we ended the class with this example, right? On page number 106, page 106, example. Page 106. The example relating to potential energy, right? So we started to solve this problem, but I don't think we couldn't finish it. So today we are going to discuss about this one. Everyone should have your textbook in front of you. Okay. So come to page number 106 and look at the example. So here a body of mass 10 kg falls on a spring with a velocity of 10 meter per second. So the mass of the object is 10 kg and the velocity of the object is 10 meter per second, and if the spring constant k is given as 10 100 and 30 joule per meter square, joule per meter square. What is the compression? That is the value of x, right? Now as we know, if a body is falling downwards, okay, a body is falling in the downward direction, okay, the mass of this one is 10 kg and the velocity of this one 10 meter per second. So I can easily calculate the kinetic energy of the body, right? The kinetic energy of the body will be half mv square, okay? So half mv square, if I calculate, it will give me 500 joule, right? Now it was falling down, right? And there was a spring. Let us say there was a spring, and when it fell down, what happened? It fell on the spring, and it compressed the spring, let us say by x amount. This is our compression, right? This is our compression. The spring was in this situation, but as the body fell on this one, the spring got compressed, and this is the amount of compression, x, right? We have to find this compression. Now, as you can see, this body was falling, it was having some velocity, and as a result, it had some kinetic energy, right? But as soon as it fell on the spring, the kinetic energy becomes zero because the body became static, right? The body is not moving anymore. In this position, if you notice, the body is not moving anymore, so the velocity is zero, and if the velocity is zero, there is no kinetic energy. Now, where that kinetic energy went? Okay, we will study conservation law of momentum. There you will see that energy can neither be created nor be destroyed. It can only be transformed from one form to another form. So here it was kinetic energy. Definitely it has been transformed to another form, right? Another form of energy. So that is actually, that will be stored here as potential energy. You know this one, right? We saw that with spring here also. When we compress the spring, we are doing some work, and that work is stored in the spring as potential energy, right? So using that potential energy, it can spring back to its original position when we withdraw the force, right? Now, if I take out this object, what will happen? It can come back to its original position, correct or not? So definitely it has some potential energy. Using that potential energy, it will be able to come back to its original position. That means it can regain its state. So now the potential energy that is stored in the spring, we know how to calculate this one, right? That is half kx squared. Potential energy stored in spring. Stored in spring is equal to half k x square. Here k is the spring constant and x is the amount of compression. Now, can I write according to the question? Let us say this is ES, okay, or is called EP, okay, as it is potential energy. Let us write this one as EP. Now, according to the question, can I write EP is equal to EK? I can easily write, okay. I will give you an example. Let us say me and GM, okay. I give GM 20 taka, so how much GM will receive? Obviously 20 taka. আমি ওকে যত টাকা দিব ও ঠিক তত টাকাই রিসিভ করবে, ঠিক কি না? ঠিক একই ভাবে এই যে বডিটা যখন এখানে পড়লো, বডিটা যতটুকু এনার্জি লুজ করবে, স্প্রিংটা ঠিক ততটুকু এনার্জি গেইন করবে। বডিটার এনার্জি ছিল 500 জুল, রাইট? এখন স্প্রিংটার কি হলো, স্প্রিংটাও ঠিক 500 জুল এনার্জি রিসিভ করবে, বিকজ ওর এনার্জি এখন জিরো হয়ে গেছে, তাই না? আমি আবারও বলি, বডিটার এনার্জি ছিল 500 জুল, বডিটা যখন এটার উপরে পড়ে তখন কি হয়, বডিটা এই যে এখানে স্ট্যাটিক হয়ে গেছে, তার মানে ভেলোসিটি জিরো, ভেলোসিটি জিরো মিন্স কাইনেটিক এনার্জি জিরো হয়ে গেছে। 500 জুল থেকে কাইনেটিক এনার্জি জিরো, দ্যাট মিন্স এই এনার্জিটা ও কি করছে, এখন স্প্রিংকে দিয়ে দিছে অ্যাজ আ পটেনশিয়াল এনার্জি, রাইট? সো বডির যে কাইনেটিক এনার্জি ছিল, বডি যতটুকু কাইনেটিক এনার্জি দিবে ততটুকুই পটেনশিয়াল এনার্জি স্প্রিং গ্যাদার করবে, ঠিক আছে? মানে আমি যতটুকু দিব আরেকজন ঠিক ততটুকুই রিসিভ করবে। সো আই ক্যান রাইট দিস ওয়ান, রাইট? So now if I put the value half k x square is equal to half n v square. Now ek we already calculated 500, so half into, and kf also we know, this one we can write as 10 to the power 5 into x square is equal to 500 joule. Okay, so from here I think you can easily calculate the value of x. It will be 500 into 2 divided by 10 to the power 5. That means 1000 divided by 10 to the power 5. It will be 10 to the power 3 divided by 10 to the power 5. So it will be 1 by 10 square. That means 1 by 100. Okay, 1 by 100 means 0.01. Is it meter or centimeter? Definitely it is meter. Okay, 0.01, this is meter square, because this is x square, sorry, x square. So from here I can easily calculate x is equal to, if I take root over, it will become 0.01 meter. Okay, I think now it is visible to everyone. Okay, GM. Yes, GM.
Sir, can you explain me from where did you get the 10 to the power 5?
Actually, see, 1, 2, 3, 4, 5. 5 zeros are there, right? So this can be written as 10 to the power 5. Okay, this one you will
Short form.
study,
Okay.
yeah, short form. If you have 100, right? After 1, how many zero you have? 2, right?
1.
You can write it 10 square. No problem.
Okay.
You see, 10 square means what? 10 into 10, and 10 into 10 gives you 100 only.
Yes.
And then Robin, any other doubt you have?
Yes, sir. That formula EP equal to half kx square.
Yes, that one actually we got in case of a spring. See, in page number 106 at the top. This is the potential energy in case of a spring. Remember this one. We will use potential energy is equal to half kx square only in case of a spring. Okay?
Okay, sir. Okay.
Spring constant. This is K is spring constant. This will be considered in case of only a spring only. Okay? Any other doubt?
No, sir.
Okay. Now, Robin, what is your doubt?
স্যার আমি একটু পরে আসছি স্যার। এক্সট্রা আপনি কি বলছেন আর কি, এক্সট্রা আপনি কি ধরছেন?
X is the compression. Initially, when there was no force on the spring was like this. Now, when this object fell on this one, definitely it will be compressed a little bit. Okay, how much it got compressed? This is X, the compression. How much it got compressed?
Okay, sir.
Okay.
Okay. Okay.
Anybody else have any doubt? GM and Robin, lower your hand if you don't have any doubt. Acha, okay. So I guess we can move forward. Okay, now we know how to calculate the potential energy in case of a spring, right? Now let us say we don't have a spring, we are doing some other kind of work. Okay, let us say I have an object here on the ground. I have an object of mass m, and I lift it up to a certain height. Let us say I lift this object to a height of h. Okay, this is the same object. Now, this object was on the ground and I lifted it up. Definitely I have done some work, right? Because I have applied some force on this one. Let us say the applied force is F, okay? And due to that force, there has been some displacement, okay? So whenever there is force and due to that force, there is some displacement, you can say that we have done some work, right? And as I have done some work, definitely I have lost some energy, and that energy has been stored in this body as potential energy, because this body is not moving now, right? We already studied this one in the last class. If the body is not moving, okay, due to the position of the object, see, the position of the object is here now, and that is at a certain height from the ground, okay? So due to the position of this object, this body gains some energy. That is from me, okay? The energy lost by me will be equal to the energy gained by this body, okay? I hope you all will agree, okay? Now what is, see, we already said that the work done is equal to the energy, right? Okay? The work done by me is equal to the energy lost by me, and the energy lost by me is equal to the energy gained by this body. I will say again, the work done by me is equal to the energy lost by me. Okay, আমি যতটুকু কাজ করব ঠিক ততটুকু এনার্জি আমার লস হবে, এবং আমি যতটুকু এনার্জি লুজ করব ঠিক ততটুকু এনার্জি ও গেইন করবে। জাস্ট লাইক আমার যতটুকু কমবে ওর ঠিক ততটুকু বেড়ে যাবে। তো তাইলে আমি কি ডাইরেক্ট লিখতে পারি the work done is equal to potential energy in the body, because potential energy is equal to the energy lost by me. The energy lost by me is equal to the potential energy of the body. So we can write this, huh? Now EP is equal to W. W is the work done here, right? So work done I can write as force into displacement. Correct or not? Now, what is this force? This force will be equal to weight of the object. Okay? EP is equal to force is the weight of the object. So weight of the object is mass into acceleration due to gravity into h. Okay? Into h is there. Okay. Now, why the force is mg? Remember this one, whenever you are lifting some body, if you want to lift the body, you have to apply a force equal to the weight of the object. Okay? Now, if you are raising a very light object, you have to apply a very light force, right? খুবই কমফোর্ট দিতে হবে যদি হালকা একটা অবজেক্টকে তুমি করে তুলো, বিকজ ওটা ওয়েট কম। এখন if you want to raise a heavy object, you have to apply a heavier, larger force, right? Why? Because the weight of the object is higher. তো ওয়েট যত বেশি হবে, ফোর্স আমাদের ঠিক তত বেশি দিতে হবে। তো কোন একটা বডিকে উপরে তোলার জন্য আমরা যে ফোর্সটা দিতে হবে, সেই ফোর্সটা কি অবশ্যই সেটার ওয়েটের ইকুয়াল। ওকে, F will be equal to mg. Remember this one, okay? Whenever you are lifting an object, I'm saying this again and again, okay? Whenever you are lifting an object, you have to apply a force on the object equal to the weight of that body. Mahmoud, you are unmuted. You want to say something?
Sir, what did you get FH?
FH, work. Work is equal to force into displacement. The very first topic of this chapter was work. So how do you calculate work? When you can say you have done some work, when you apply some force on an object and you cause some displacement. And if I tell you to calculate the work, what you will do? You will multiply the applied force and the displacement. That will give you the work. Okay?
Okay, sir.
Okay. So this is the new formula. Okay, this is the actual formula to find out the potential energy of any object. Okay, that has been raised. So remember this one. This is for this case. Whenever we are raising an object from the ground to a certain height, definitely I will be doing some work, and if I do some work, I will be losing some energy, and that energy will be stored as potential energy within this body. Okay. Now here it was on the ground, right? So here the potential energy was 0. Okay, now I have raised it to a certain height. Now it will have a potential energy that is equal to mgh. Now here also it is 0, we can prove this. Okay, we know that EP is equal to mgh. Now mg is the weight, okay, into height from the ground. If the object is on the ground, then there is no height, the height is 0. So in this way also we can say that the potential energy of an object on the ground is 0. When we raise it to a level, we do some work, and that work is stored as potential energy in the object, and then we get a value of potential energy through mgh. Okay, we will try to solve this. We will try to see an example. Okay, the application of this one I will show you. Till now, anybody have any doubt? Raise your hand. Nobody. So let us say I give you an example, okay? Let us say I have an object of mass 5 kg on the ground, and I lift it to a height of 50 meter. Okay, this is the same object, 5 kg. Okay, so now calculate. Let us say this is the position A. This is the position A. Now calculate the potential energy at A. Okay, so kindly start solving this one and let me know the answer. Let's see who can tell me the answer the fastest.
স্যার গ্র্যাভিটিটা জানি কত 9.98
9.8, my boy.
9.8 okay.
I could also calculate with you. Done calculation. Okay, so what will be the answer? Nobody?
Sir, 2450.
Very good.
1450.
Yes, exactly.
Yeah, correct. Yes.
Okay, so it is mgh. So m is what?
Yeah.
Mass. This is 9.8 and this is 50. So if you can multiply 2450, and as this is energy, joule. Okay, so if I want to convert it into kilojoule, then I have to divide it by 1000, right? 2450 divided by 1000. So as there is 30, 1, 2, 3, the decimal will come 1, 2, 3, 3 places left. Okay, kilojoule. This is just in case you have been asked to find out answer in kilojoule, okay? Or else it is not actually necessary to find the answer in kilojoule. If you want, you can put it in joule also. So clear how to calculate the potential energy of a body in case we raise an object from the ground to a certain height. Okay? Okay? Nobody raising hand. That means we understood. Acha, today what happened is many of the teachers were told not to come to the school. Those who are coming to the school by school transport. Okay, so as a result, what might happen is many of the teachers might not take your class. Okay, so if you inform me beforehand that you are free in this period, I can take a couple of more periods to cover up. We already lost so many classes, right? So it will be better if you could do some extra classes to cover up the topics. Okay. Mahmoud gave life. Okay. Nice. So let me know beforehand, okay? It's not like, at 11:20 the class is about to start and you tell me at 11:19, sir, we have this period free, can you take it? Okay, just try to let me know 10 to 15 minutes before so that I can take some preparation. And also I have to check whether I have any other class in that period or not, okay? So confirm with your teachers that who are going to take your class and who are not, okay? Then if you find any free period, you can let me know, okay? Then what we have, okay, I will suggest you, to go through these paragraphs. Page number 106, starting from bottom, okay, you can go through up to the example, okay, this part. Then next page 107 up to this part. Very necessary information is given and almost the same thing that I have explained you here. But if you find anything new or if you find any line that you don't understand, sir, what they meant by this, you can ask me, okay, in the next class. And today, let me check what we can do now. Okay. The next topic that I can discuss with you is conservation law of energy. Okay, this is another important thing. Did you go through this one in grade 8 or something? Conservation law of energy in science?
No, sir.
Okay. Okay, if you remember, we already studied in the fourth chapter conservation law of momentum, right? So whenever we are saying conservation of momentum, that means the total momentum remains same. So now we are saying that the conservation law of energy, that means the total energy of the universe always remains same, okay? Nobody can produce or destroy any kind of energy, okay? Energy can only be transformed from one form to another one. This is what I was just saying, right? So, one of the most important laws of physics.
স্যার আপনি উপরে কি লিখছেন WPE
The same question somebody else asked me. GM asked me in the last class. This is work, power, energy, the name of the chapter. Okay, our class is almost about to be finished. Okay, so it has an explanation. Okay, I will prove this law. As you remember, I proved the conservation law of momentum. Also, I will prove the conservation law of energy. Okay, so but I don't think within this 4 minutes it is possible to finish. So rather, I choose not to start now. In the next class, inshallah, I will show you. So please try to let me know beforehand if you are willing to do an extra class. Okay. And that will give me some opportunity, if some other day you are tired, okay, you are not being able to do the classes, then I can give you some free period also, okay? So today we have chance, let us try to utilize it, okay? So I think there is no need to explain this one, okay? As I already told you, energy can neither be created nor be destroyed. It can only be transformed from one form to another, okay? Now, as you already saw previously, we were solving an example where the body fell on the spring, right? So when the body was falling, it was having some kinetic energy, and when it fell on the spring and became static, the velocity is 0, so the kinetic energy is also gone. Now, as the kinetic energy is gone, can you say that the kinetic energy has been destroyed? No, it has been passed on to the spring as potential energy. So see the change of form. It was in the kinetic energy form first. Now it is in potential energy form. But the amount is equal, right? The kinetic energy lost by the body is equal to the potential energy gained by the body. Okay, it is the same amount of energy, just in different form. Previously it was kinetic, now it is potential. Okay, this is what actually this says. Energy can neither be created nor be destroyed. It can only be transformed from one form to another one. Okay, thank you for joining. See you in the next class. Assalamu alaikum.